go here. So let me share my screen and we'll get started.
All
The
right.
very first thing I'm snipping in here, it says to show the equation as a system of equations. What they're really telling you to do is to solve this, and that's what you have to be able to do. You have to be able to solve what's called an absolute value equation.
Uh-huh.
Okay, and you do this with the following. You write what's inside the absolute value 2 times. And in the to the right of the first equal sign, you put the number that's there.
Mhm.
To the right of the second equal sign, you negate the number, and that's -11.
Do we do that because of absolute value?
Yes.
Okay.
So
I guess that makes sense.
let's talk about what this actually is. The left side is a V. It's a graph of a V. Do you remember that? The absolute value is a V.
Yeah.
The right side is a horizontal line. How many times does the horizontal line hit the V?
Twice.
So there's 2 equations for that.
Oh, okay, that actually makes sense. And then it's also they're gonna be like the same, but
Kind of.
yeah,
Let's
like
try
almost.
to avoid drawing generalizations a little too soon here. So
Uh,
you know how to solve these equations. You subtract 7 from both sides. So x equals 4. And this other one, x equals
-18.
-18.
And then would you
No, this is it. You're done. There's
okay.
nothing more to do here.
All right, sweet. I like that.
All right, let's try another one here. And then I'm going to transition to Desmos to show you some things about absolute value that I think you'll appreciate. So again, whenever you're solving an absolute value equation, you write what's inside the absolute value 2 times.
Mm-hmm.
There and there. To the right of the first equal sign, you put the number 4. To the right of the second equal sign, you put the negative of that number.
Mm-hmm.
Okay, and then you solve it.
So that would be x equals 1, and then x equals -7.
Okay, great. Now I'm going to switch sharing. But let me just clean up this graph. All right, so I'm going to go to Desmos, and I'm going to ask you some questions that you actually know the answer to. Here is the absolute value of x graph. Okay, and it's a V-shaped graph. You see that, correct?
Yeah.
Okay. If I draw a horizontal line like y equals 2, how many times does it hit the graph?
Twice.
Okay, so here's the question, and I've got to do it verbally.
Or
Yeah,
actually
that's
once.
correct. No, twice.
Oh, okay.
Boom, boom.
All right.
Can you see that on your screen?
Yeah, mine is 2 and 2 and 2 and 2.
Okay. This is the question. This is the important question. I'm gonna do it verbally. I'd love to write it down, but you can't see it. Does every horizontal line hit this absolute value 2 times?
Yes.
Okay, so let's try this. Does 3, does that work?
Yeah.
How about 4?
Yeah, that works.
How
Would
about
it?
-4?
No.
No,
And then 0 wouldn't work either. That's just 1.
that's right.
Okay.
So let's go back to the other screen now that we've talked a little bit about this, and I'm going to share that. And what you have to remember about the absolute value is that the absolute value, and it does not matter what is inside the absolute value,
Mm-hmm.
the absolute value always produces positive or 0.
Absolute values was
So let me give you some numbers. What is the absolute value of 1?
1. Wait, so
What
I'm
is
a
the
little bit
absolute value?
confused for the 0. So 0 is just always 0. Like you can't ever change
Yep.
that.
What about the absolute value of -1?
Positive 1.
Can I ever get a number that isn't like, can I get a negative number on this side?
Unless you have a negative before the absolute value.
That's true. That's true. So let's go back and look at that in the graph, because that's actually very important kind of to talk about here. Let me go back to the other window. So you just said something very important. Let's say I put a negative there. Now, how many times is it hitting?
Twice.
Twice. Okay. So that's important. It does matter where the negative is to answer this question. Okay. But absolute value, the absolute value part always returns positive. The negative just changes its sign.
Mhm.
Okay, so here's why I'm asking these questions, or this is why we're talking about it, is at some point, and maybe it's the next one on this worksheet you have, you will get something like this: absolute value x plus 4 equals -2. Is this possible?
I don't think so.
No. Now let's go back to the other graph and let's look at the graph and let me show you why this is not possible. You're seeing my screen again, the graph of this?
Yeah.
Do these intersect?
No, they don't.
They do not. So there's no solution to this. Okay, but let's go back to this. You can still find solutions. Okay, like you can still do what I said before. X plus 4 equals x plus 4 equals -2, +2. You can subtract 4. You can subtract 4. And you can go on your merry way and you can think, I got it. I understand this. But what is the answer here?
No.
There's no solution.
So then, all right, my question is for those, like, how does that compare to the graph?
Well, we just graphed this. The absolute value of x plus 4 is this. It V's, and here's y equals -2.
Mm-hmm.
Do they ever intersect?
No.
No. And that's the only time there's a solution is when they intersect.
Okay.
So what I'm trying to tell you is that you're going to get a problem like this on your test, and you don't want to do this rest of this.
Do which part?
You don't want to do everything down below this line.
Oh, okay.
Like you want to stop here. You're driving now, right? So, you know what this is. This is a stop sign.
Yeah.
You want to stop because it's not possible. So if you have the absolute value of something equaling a negative number, there is no solution.
So unless there's a negative before the absolute value, right?
That's right. That's right. That's different. And that is okay.
That I don't even need to do that down there because it's just no solution.
Yeah. So let's actually, I just see this now. Question 2 has kind of what I'm asking you to do here. Let's look at that. So here's question 2. And this negative really goes with this. It's really -3 here. So in full disclosure, in the previous problems here, it was already solved for the absolute value on one side of the equation. The absolute value was already on one side of the equation. The absolute value was already on one side of the equation. Here in this problem we're looking at now, there's this -3 out in front. You have to undo that first. You have to undo multiplication, division, addition, and subtraction. You have to do all of that and then make a decision.
All right.
So what I'm saying here is you need to undo -3.
So divide it by 3?
Yes, by -3.
Oh, yeah. So that would make it, wouldn't the bracket become, well, it's going positive anyways.
No. We're just dealing with this. The absolute value is we're not touching.
Oh, okay. So then +3.
That's right. This is okay. Okay, let me try and do a bit more of this because I can see there's a gap here.
Yeah, I think I'll just need like one more example. I'll get that
Yeah.
because like I kind of understand that.
Okay, so let's say I give you absolute value x minus 3 plus 4 equals I'm sorry, let me do it this way. Let me do minus 4 equals negative 2. Is the absolute value by itself?
Yes.
No. There's this minus 4.
Oh, my bad.
Right,
I
right.
was like looking at it straight in front of it.
Like it is if you just say that's the only thing there, but this minus 4 is here.
Yes.
So you have to add 4.
4 to both sides. So then x minus 3 equals 2.
Absolute value of x minus 3 equals 2. Is this
Right.
okay?
Yes.
It is, okay? But now let's look at another one. Let's say it's absolute value x minus 3 plus 4 equals negative 3. What is the first thing to do here? You have to isolate this absolute value, which means you have to undo this other stuff.
So you have to subtract 4.
Yes, so this becomes the absolute value of x minus 3 equals negative 7.
All right, and then
Is that okay?
No. Because
No.
it's negative.
So what you have to be able to do is get the absolute value by itself on one side of the equation and then see if it equals a positive number or 0. That's the only time you can do it.
All right. So then, wait, sorry. Say that just like one more time for me, because I'm not sure if I like fully got that.
Yeah, well, let me just give you another example here. So let's go absolute value x minus 2 plus 5 equals 5, and let's put a 3 out in front. So what's the first step here?
You're gonna have to subtract 5.
Subtract 5 from both sides. So you have 3 absolute value x minus 2 equals 0.
And is it I continue the problem normally, even if it's still 0 right there?
Well, you have to undo this first.
So then minus 3?
Divide by 3 because it's multiplying.
So then just x minus 2 equals 0.
Yes, and this is okay. As long as this number right here is 0 or positive, it is okay.
All right. Oh, right, because that's the line would be on the 0 or
right. So see how you have to get this absolute value on its own, because I can make something that looks like it doesn't work. Like let's say it's absolute value of x minus 1 negative 2 plus 17 equals negative 19. This looks bad from the beginning. But when you get it down to x minus 1 equals, that's what you care about. Is this number right here? Is it 0 or positive?
Or 0.
So notice you're going to subtract 17 from both sides. Doesn't get any better at the moment. It's negative 36. What do you do next here? You divide by
2.
Negative 2.
Negative 2. So you always divide in this situation?
You divide by the number that's in front. You want to get this. So okay. What maybe isn't clear here is this thing that's absolute value. You're treating it as if it's like x.
Okay, so you got to get all of it on the other side.
Yes, yes. You're treating it like it's x. Like when you were solving two-step equations, you just treat it like, oh yeah, that's x.
All right, so then. All right, I think I got that. Can I have another one?
Of course.
All right, thank you. So for one like this, you have to add 3.
Okay, agreed.
Making it minus x minus 2, or minus absolute value x minus 2
Yes.
equals 7.
Right.
And then
you have to undo this. So there's really a 1 here. If you want to write it that way, that's okay.
Oh, so I'm gonna divide by 1 still.
Not 1. What is the number in front?
-1.
Yes.
So then -7.
Yes. Is this okay?
No, it's not 0 or positive.
So there's no solution.
All right, so then I just write no solution.
Yes. But you show all this work because you're justifying it based on this step at the end.
Mhm. All right. So, and that's why it's 1, and the absolute value will make the up. Okay, so my question is, so when there's like the absolute value, like before it makes like when you write the 2 examples.
Well, it's
One-
got to be a positive. Like let's do some of this. Let's go 2x minus 1 absolute value equals 3.
Mhm.
So you write 2x minus 1 equals 2x minus 1 equals, but you do this because this is positive
Positive.
or 0.
Oh, and then when it's gonna be negative or not 0, then yeah, what I just
If instead of 3 it's -3, you just say no solution. You stop.
okay, sweet. So then I just save myself all that time.
Yes, you will get something like that in the test. I mean, most of them will just be equals a number or equals 0, but a positive number equals 0, but you have to look out for that.
All right. Okay, that makes more sense now.
Okay, so can you solve these 2 equations for me?
Yeah, 2x equals 4, then x equals +2,
Good.
and then 2x equals -2, x equals -1.
Yeah. So it's actually the exception that they're positive and minus of each other. They're usually not in the same space.
Mhm. So my question, I don't know if I already asked this, and there was already explanation, but getting those 2 answers like that, x equals 2 and x equals -1, like what exactly is that doing?
You're asking for the geometric interpretation of this, is what I'm hearing.
I think so.
Okay, so if I make a really crude graph of this, 2x minus 1 looks like this, and x equals 3 is, or y equals 3 is here. I didn't quite get it, but it hits there, and that's at -1, and that's at 2.
Oh, okay. So we're not looking at it as like 1 and -1 and 1. We're looking at it as just -1. And then instead of like 2 and 2, we're looking at it as just 2.
Well, you just, the x coordinate is all you care about.
All right. Yeah, that's a better way to word it.
Because the y is kind of given. The y is 3.
So then, okay, that makes more sense. Yeah, y is 3, and then that's the x.
Like the problem could say find the intersection points of absolute value 2x minus 1 and y equals 3. And it's the same problem because you set the y's equal. So you get 2x minus 1 equals 3 absolute value. And you write the 2 equations that we just wrote. And you solve them, you get x equals 2 and x equals -1. But the other ordered pair that goes with it is from here. So y is 3 and y is 3.
Okay, yeah, that makes. Oh yeah, that works.
But in your problem, you're just asking for the x values. They're just saying, what's the x value?
All right. And then in order to, if they're asking for the x and y value, I already know what the y value is.
Yes.
Okay. So it's like, in a way, it's kind of like the parent functions.
Yeah, yeah. Okay, let's move on to some graphing. If that's okay with you, if that's
Great.
great. So some graphing here. First one is right there, g of x. Okay. And there's a bunch of things they're asking you to find. All right.
Are you doing this on Desmos?
No, I'm just getting back to
Oh,
where
okay.
yeah, give me a moment. So do you see this now in g of x equals 1/2 x plus 8? Are you seeing that?
Mhm. Yeah.
Okay, so the first thing it asks for, like part A, is the vertex. So the vertex is it's x minus h plus k. Your
Mhm.
vertex is h comma k. And it's kind of like when we were doing the parabola problems, it's very similar to that. So h comes from the number inside the absolute value. What is the number inside the absolute value?
8.
8.
Positive.
But h is not, h, you have to account for this negative sign. So h is actually -8.
All right.
You follow that? It's like +8 equals -h,
Mhm.
or it's the opposite of what's in here.
But then the absolute value, wouldn't that make it positive?
We're just talking about the vertex. We're not evaluating it. We're not like putting a number. We're just trying to figure out what h is.
X minus h. All right.
So the way you can remember, way most students remember it is it's the opposite of whatever's in here. If it's +8, it's -8. If it's -8, it's +8.
So
And
then,
we're talking about the h value. So k is the other number. K is -3.
mhm. So then that's the vertex.
Yeah. Now just real quick here. If I wrote y equals 1/2 x plus 8 squared minus 3, and I asked you for the vertex, it's the same thing.
So
You look inside here.
when I'm looking, all right. So if I'm looking at this, let's say it was x minus 8 instead of x plus 8.
Okay.
I write it as +8.
That's right. Yeah.
So it's going to be, when it's an absolute value for the vertex, it's just going to be swapped, like the negative or positive.
Sure. And it's the same here for the quadratic also.
All right. So then 8 goes to -8 and -3, and then -8 would go to 8 and -3.
Yes.
Okay.
All right, great. So the next question, I'm going to snip this again here. It says, what is part B is what is the y-intercept? So the y-intercept is when x equals 0.
-3.
Nope, that's the vertex. You have to put 0 in for x. You're literally finding g of 0. Wherever you see an x, you put a 0 in.
Oh, okay.
So this is where you actually have to like add and then take the absolute value and multiply. I'm sorry.
Would it be 1?
So 0 plus 8 is 8. Absolute value of 8 is 8. 1/2 of 8 is 4. 4 minus 3 is 1. Yes.
Okay.
So this is an ordered pair though, meaning like what you just found is that y equals 1. So that's an ordered pair 0, 1.
So then,
That is the y-intercept. The y-intercept is an ordered pair.
okay, the y-intercept is an ordered pair.
It's on the graph where it crosses the y-axis.
So then, what would my next step be for this?
That's it. I mean, that's it. So we're going to do the x-intercepts next.
Okay.
Do you see on your paper how it says find the key characteristics and label them in the graph?
Yeah.
We're just going through them one by one.
Okay. And those, it's like the x-intercepts, y-intercepts, vertex.
Yeah, so I'm calling part C the y or the x-intercepts. So the x-intercepts are when y equals 0. Do you see a y in this graph, in this equation over here on the left?
I don't.
Now do you see a y?
I do.
You do. So g of x is really y.
So g of x means it's okay. Yeah. That makes
So when
sense.
you're finding the x-intercept, you're setting y equal to 0. 0 equals 1/2 absolute value x plus 8 minus 3.
So then you'd have so if it's not equals -3, then you have to do oh my god, I just forgot its name. It would be -8 and -3. It's
Well, no. Let's go back and look because you did a bunch of these. What did you do? What did you do here in this problem?
I added 3.
Why? What was your goal?
I wanted to get the x by itself.
The absolute value by itself. So let's go back and look at your problem. Is the absolute value by itself?
So then, oh, there's already the 0 over there. So would I be adding 3 to both sides?
Yes, you're going to add 3 to both sides.
All right, so then 3 equals 1/2 absolute value x plus 8, and then I'd divide 1/2 and 3.
Yeah, but you don't want to divide by fractions, so you multiply by 2.
And then that would just give you 6 equals x plus 8. And then
Yes.
you continue with this since it's positive number, not a negative. So then that would give you is it okay if we switch it so it's x plus 8 equals 6?
Yes, that's preferred also for me.
Yeah, I don't know. It's like my brain's just like, huh. So then you're gonna switch the 6. So the first one is just x plus 8 equals 6, and then the second, because the absolute value, x plus 8 equals -6. And then that would give you x equals -2 and x equals -14.
Yeah, so x equals 2, x equals -14. Perfect. Okay, so before we do any more of the like questions on your domain and range, I want to really quickly have you do another question that's on here because it's really similar. I want you on your own here to try this problem. I want you to solve that for x, please.
All right. Okay, I got it.
Okay, can you just give me another 30 seconds here? Just want to take a break.
Yeah,
I really appreciate it. I just need a little time here.
Yeah, of course.
Zach, you still with me?
Yeah, I'm here.
Okay. What are your two answers for this?
I got x equals 0 and x equals -16.
Okay, so here's how I check your answers. I'm going to actually plug them in to the absolute value function or the equation. So we have 0 plus 8, okay, 8 1/2 of 8 is 4. 4 minus 3 is 1. So that works. And then I can do the same thing with the other one. I can just try it out. 1/2 negative 16 plus 8 minus 3. Now you don't want to do it this way. You don't want to actually solve it because you know this you would be guessing and checking forever. But yeah, they both work.
So, all right. So what I got was correct. Right.
Yes, perfect.
Okay. So that one, and then if there's like, if I were to graph that, I'd be
You don't need to graph it. I mean, as far as I'm concerned, but we can talk about that if you want. Yeah, let's all right, so let's see here. Let me go back to your thing here. Okay, so let's talk about domain and range. We have not talked about domain and range at all, but we can do it relatively quickly here for this function. So here's the original function that we're given. The domain of these is always minus infinity to infinity, or it's that x such that x is an element of the real numbers stuff. Do you remember that from before?
yeah.
Okay. The range depends on two things. It depends on whether it opens up or down, and it depends on the vertex. So does this open up or down?
Wait. Yes, it's going up.
Going up. So when it's going up, the range is y greater than or equal to. When it's going down, it's y less than or equal to.
And then like vertex. So then we're gonna figure out the vertex.
Yes, or you actually have it. Do you have the vertex?
Yeah, it's -8 and -3. Right.
Yeah.
Okay.
So the up or down depends on this number here. So it's -3 or -3. In this case, since it opens up, we go with this one. So the range is y such that y is an element of the real numbers, y greater than or equal to -3.
All right. So then we've figured out the x. No, we haven't figured out the x and y yet, correct?
Say that again.
So like the next step for this would be like figuring out the x and y.
No, we already have it. Like we have the range and the domain are given. Like these are the answers.
Okay.
There's nothing more to it.
All right. Man, all right. This is like kind of easier than less stuff to do than I thought it would be.
Okay. So let's do another one here. Let's say, well, you actually have another one here on your paper here. Yeah, let's look at this next one. Okay, so let me snip this in and so this one right here, what is the vertex? The vertex is h comma k, and I'll write it out here, x minus h plus k.
All right, here, I'll just start solving it. Oh, wait, no, the vertex is the easy part. It's positive 5 and 4.
That's right, it's 5 comma 4.
Yeah, I don't know what I was doing there.
All right, so that's our answer for the vertex. That's kind of part A. Part B was to figure out the y-intercept. The y-intercept is when x equals 0. So you're literally putting 0 in for X. Wherever you see an X,
Oh,
you're
right,
putting in a
okay,
0.
Minus 2, absolute value 0 minus 5 plus 4.
Yes.
Then that's minus positive 5.
Yep.
-2. So would that be -6?
It is -6. Very good.
All right.
Okay, so that's maybe part B. Okay, so now we'll do part C, which is determining the part C is determining the X-intercepts, and the X-intercepts are when Y equals 0. Is there a Y in this?
Yes, the H and X.
Okay, so that's your Y. So you set 0 equal to that. Now, like you told me earlier, and you can actually do this at this step right here. You can actually just put the 0 on the right. You can rewrite it like this, where it's the same, but the 0 goes on the right-hand side.
Okay. I think I just like that more just because it's like, I don't know. I guess I was like taught to do it.
No, I like it too. I like the number on the right. So from here,
Subtract 4. Right.
you subtract 4.
And then that would be minus 2 absolute value X minus 5 equals -4.
Yes.
And the -2, I just divide all those by -2. So then this does have a solution because it's a positive number. So then you'd have to write that out.
Yes.
So then you'd
So
have
you got X minus 5 equals 2.
and then
X minus 5 equals -2.
And then that would be X equals 7.
Perfect. And then X
X
equals
equals 3.
perfect.
And then that's it, right? Or is there, I feel like we're missing something.
No, that's it.
All right.
Okay, so does that kind of feel like okay? Do you kind of, you're like, okay, I kind of understand that?
Yeah.
Okay, so the domain is always all real numbers. Okay, so you've got to write that X such that X is an element of the real numbers with the curly braces around it.
What are these called again? I always forget.
They're curly braces. They're,
Oh, so that's like their actual name.
Yeah, I think so.
Oh.
They probably have a slang name or something. Like the exclamation point in programming is called a bang. This is called a pipe in programming. I don't know.
Yeah.
I mean, I didn't make these things up, but there's this nomenclature.
Yeah, some stuff's kind of like that.
So the range depends on whether it opens up or down, plus the vertex. Okay, so let's go back and look at your original thing here. Let me go grab it. And you tell me, does this open up or down? And if you're not sure, go to Desmos and graph it.
It's going down.
It opens down. So when it opens down, it's a Y less than or equal to, and the number here comes from the vertex. So yeah, you need the vertex. The vertex you told me was 5, 4. It's the 4 that you use.
So then.
And you still need that Y such that Y is an element of the real numbers, comma, with the curly braces around it.
And then that would be, and then
that's your range.
Domain is like the same thing, but it's just X's and there's no like greater than.
Yeah, it's everything, yeah.
And then
what is your frustration? What is not clear?
I don't, what's there like, I just, I don't know what it is, but I keep getting like lost because I kind of feel like there's like another step.
No. I mean, this is, okay. If you look at your instructor's asking for a lot of things: vertex, y-intercept, x-intercept, domain, range. There's a lot of things there, but this is it. We're done with the range. We're done with the domain.
So then, yeah, I get that with the domain and range part. Like, is there any more steps to this problem, or is that just kind of it?
I'm not. We're not graphing it. We could, but I'm trying not to focus on that tonight. Trying to focus on this other more mechanical stuff.
All right.
Let's do one more. We got time, I think, for one more. If you're up
Okay.
for it.
Maybe we can make this one a little bit tricky. Maybe.
I don't think we're ready for that.
Okay, man. I guess they get a lot harder than this then.
No, they're not that much harder, but like, let's just reinforce the concept here. Okay. So the first thing is, actually, I just want you to solve this for X. Okay. So we've already done a couple like this, and then we'll do a spin off on this. So
we already know the, oh my, it's not, not domain, it's vertex.
well, we're not, if this were a Y, that would be true, but we're not given that. But let's do that. Let's say this is a Y. What is the vertex?
Shoot, I think, wait, what was that number that's covered up?
We're calling it Y.
Okay, sorry, I got
so this is Y equals negative absolute value X minus 4 plus 5. And the vertex is 4
and 5
or 5.
Okay, and then there's the Y there. Okay, all right, that makes sense.
So now let's do the Y-intercept, and that's when X equals 0.
Okay, so
every function has a Y-intercept.
Okay.
Well, that's not true, but it's true for a lot of things.
All right, minus X. So would I subtract the 5?
No, you're putting 0 in for X. Wherever you see an X, you're putting a 0 in, right there.
Minus absolute value 0 minus 4 plus 5 equals Y. Then that's negative 4 plus 5, Y equals 9.
I think it's 1. You got negative 4 plus a 5. This negative comes from the outside.
Wait a second. So if it's the negative, and then
you have to take the absolute value first.
Okay, yeah, I just looked at that wrong, because then there's the absolute. So a negative inside the absolute will make it positive, but there's still a negative on the outside making
That's
it.
right. That's right.
Okay.
Okay, so now let's go back to our original. Our original is negative absolute value X minus 4 plus 5, and part C is asking for the X-intercepts. That's when Y equals 0.
Mm-hmm.
So you're literally putting 0 in for Y. 0 equals negative absolute value X minus 4 plus 5. And like we talked about, if you prefer, and I think this is a good idea, is to put the equals on the right-hand side.
Yes.
You can absolutely do that.
Subtract 5.
Subtract 5, yes.
So then it's a no solution because it's negative. And the graph would also be facing.
Wait, whoa, hang on.
Oh, wait.
What about that right there?
Downwards.
Yeah, but it's
negative, so therefore it works.
It does, and because you hadn't isolated this yet, you have to divide by -1, divide by -1.
Oh, so then it's positive.
Yeah, so now it does have a solution. And it did before, it just didn't look like it.
X minus 4 equals 5, and X minus 4 equals -5. That would give you X equals 9 and X equals -1.
Yes.
Shoot, all right, I gotta look out for that next time.
You do, yeah. You got to ask yourself, is the absolute value exactly isolated, or is there still a negative out in front, or something else? Because it could make the difference.
Yeah, that was a very big difference.
Okay, I think this is a great place for us to stop, Zach.
Yeah, me too.
Thanks. I'll send you the notes here shortly. Thanks so much for scheduling. I'll see you next time.
Yeah, of course. See you
Great
later, man.
night. Bye now.